Good morning, everyone. On the screen, you can read my full name, Bart Maeyens, working for Signify since 25 years. And also on the top right-hand side, I do not want to refrain of mentioning that we are the integral and full partner of Cooper Prentalux, which is the North American brand identity through whom Signify operates. Those people that are interested in reaching out, asking more questions that you might have following this webinar, the QR tag on the screen allows you to connect straight with my LinkedIn profile, and I will ensure that any and all questions, or if you would simply like to follow me, that can happen. So, Signify, Prentalux, Cooper have 3D printing as a viable manufacturing way for luminaires. And the question always comes up first, why? Well, I think these three reasons that you can see on the screen will give you a very good idea what the initial purpose behind the 3D additive manufacturing efforts of Signify and Cooper have been. The global economy, as we have known it for the last few decades, is clearly changing, tilting and shifting to a more local economy. I think for those of you that have been recently watching any news bulletin, you might have seen things like tariffs. You might have identified that most continents are thinking about themselves first and about the global economy second. The second part, climate change. I know there's a lot of news, but fundamentally Signify from the get-go has chased the data, has analyzed the data and seen that we are in very unprecedented bad climate conditions and we need to act. Signify has deployed for that Brighter Lives, Better World, climate actions, various plans that you can follow online in all forms and shapes that Signify deploys them around the globe, also with Cooper lighting for the North American market. Now, our fundamental belief is we need to act now, and we need to act very diligently and actually lead the pack instead of as a business trailing or being someone that follows. And then last but not least, Cooper and Signify have always believed in innovations. Innovations drive the world, they make us move forward, they bring us better solutions than we had yesterday, they challenge us to not accept the status quo. Those three beliefs have come together in an effort that is the additive manufacturing. And of course, if you have three, you need to select one that will become your everlasting and central mantra. And for us, that has been the climate. What you see on this slide is our belief how we can strengthen what we do, collaborate with the market to come to a truly circular economy. And this circle, I will come back to it at the end of this presentation, shows you how we start from recycled content, how we change the manufacturing landscape, how we ensure that every resource that we touch, energy, material, is used in the most efficient manner, and that at the end of the usage of our finalized product, there is another loop that can be restarted. And that's of course where the circular economy wants to go, whether it's material, energy, that it can loop continuously and be reused so that we reduce pollution, energy consumption, and material consumption. That is the central point, besides our belief that the global economy is changing and that innovation will drive us forward. Now, how does that then become very tangibly? Let me take you through the journey of additive manufacturing as we have done it. You've seen the start is material and using by preference recycled content so that the footprint from the get-go is limited. There's many choices. PLAs are probably globally the most widely used material to print with. It melts rather easily, around 140 degrees Celsius. It prints very elegantly and very easily, and hence is probably the most common household use 3D printing filament material that you can find. There's also PETs. We all know them from water bottles, etc. This is a material that has slightly better quality aspects. It's a little bit more durable than PLA. It can resist heat slightly better. And then you can read on the screen there's polycarbonate. And that's the third material that we evaluated. And that is the toughest one. It's the toughest one in two directions. Toughest one, it can withstand UV. It can withstand shock. It can withstand high temperatures. But it is also a hard material to print because it requires much higher temperatures. It is prone to actually torque. What do we mean? Torque and warp. That the material can actually shift its shape slightly while being printed. So it's very good from a quality perspective, but very complex from a production perspective. We chose that one nevertheless. And you might ask why? Well, we're making a product where sustainability is the center. So durability has to come first. Being UV resistant, having glow wire certificates, passing all American UL and European CB requirements, that is non-negotiable. And PETs, PLAs might not do that. How are we doing on the recycled content of that polycarbonate material? You can see the graph at the bottom. Right now, I can tell you we are at 75% recycled content. Second choice you need to make once we had chosen our material polycarbonate for its durability, for its usability in the lighting industry, and we have proven that we can cycle up the recycled content continuously, right now at 75%, then you need to put it in a printer. Now, there's various ways of printing. You have fusion printing, jetting, extrusions, photopolymerization, and there's many more. We chose FDM printing, which is the fusion deposit modeling. And you can see one of the very first printer makers in the industry, MakerBot, which is way over a decade ago, had also reasonable, affordable printers. So one of the decisions was also the affordability. FDM are actually the lowest threshold on price printers available, showing by the fact that the most used consumer printing method and printers around the globe these days are all FDM based. And one big benefit, as you can see to the machine and the picture, it's fairly easy as a manufacturer to work on the machine itself, because most of the components and the hardware, as you see on this MakerBot example, are accessible. So that means also as a manufacturer, you can tune and tweak the printer. Because you heard me saying, we took a tough material, so we had to tune and tweak those printers so that our material, from granulate to filament, could be used on this platform. Then comes the next step. You need to build a factory out of this, because you will not be surprised. Myself and hundreds of thousands of people these days own a 3D printer at home. It's a vast industry, it's a great industry, and I would invite you all, please consider, as you can see on the screen, there's multiple brands where you can buy a very good desktop home 3D printer and have fun. However, we wanted to apply this for mass production. And as you can see on the printer, on the picture, on the picture on the right, we need to start building a inline, continuous operated setup so that these machines can print our very durable but yet difficult material polycarbonate at an efficient speed and of course sufficiently automated. And I will tell you that automation, from what you see there, which were the first laboratories, where we attempted how can we make a printer run longer hours a day without any stops or interruptions. How can we improve the automation so that the components are actually auto-ejected? How can we ensure that these machines are actually licensed to be used in a factory? We are heating polymers. So for health and safety, as you can see on the picture, you need to ventilate the air, subtract whatever might be harmful, put filters in place so you can capture that. Anything and everything that goes with a plant had to be discovered. And then you see where we ended up today. On the left-hand side, this is actually a real time picture of our facility in Hungary, in the middle of Europe. It's very comparable to what we have in the USA in Littlestown, very near Gettysburg, and also what we have in Atlanta, Georgia. And the name of the game is speed, and speed is equivalent that the printers can print fast and can print continuously, 24/7. Speed is also automated so that the heat up temperature for you to be able to start and print a component, the cool down for you to be able to auto eject, and this is also automation, the component, and then start reprinting. All these things have to be organized. What have we learned? Not only have we learned that from those printer desktop models, you can access them and with FDM printing start printing polycarbonate in a very sustainable way, but it took 3 to 4 years to come to this picture as you see it. Making sure that this is a safe environment for people to work in, with the exhausts, automation and safety measures that industrial equipment requires. To make sure that it becomes a viable economical situation, fast, automated and reliable. And last but not least, we had to write our own software to make sure that, of course, you govern all those machines. Whenever a machine does go in failure, that operators know where that happens. And I could continue and continue, but in view of time, I will limit that voiceover of 3 to 5 years to this. Now, once you have that, that's great. We selected a durable material, we selected a printing platform, and we succeeded over 5 years' time to build a mass production printer facility in the United States, in Europe, and also in Australia. Then you need to change the world from a people perspective. Because of course, we are now additive manufacturing. And one of the challenges is not that there is an abundance of engineers already to start. Engineering, those great women and men that innovate our world we live in through software, design, engineering, are already a scarce audience to find. But added to that, we noticed that, and we notice still today, that finding people that from the start, coming out of school, are equipped with mindset and knowledge to work optimal within an additive manufacturing platform, that is yet work to be done. It's improving a lot, but work to be done. To give you a practical example, how does it look like today for ourselves when we accept a new engineer within our team? She or he will require at least on average 2 years to evolve into what we call a mature, standalone, capable to design, slice, and make their components function in a mass production additive environment where it brings benefit. Because you can see on the screen, because we are now no longer bound to the conventional rules of creating an object, we need to reprogram our engineering and design community to those almost unlimited boundaries in the additive manufactured 3D world. Work to be done, work moving along. That's why you see these days, if you start with additive manufacturing, that I advocate the easy entry. In the lighting industry, that easy entry you can see on the picture was typically suspended luminaires. Why? They tend to be particularly round. They tend to be something that you can build from the bottom upwards in a reasonable symmetrical shape or dimension. And that means for engineers, designers, it is fairly, well, easy is a word I've now used a few times, but it's within a realm of 9 to 15 weeks, something that people in additive manufacturing can learn how to do, how to make your CAD drawing into a G-code, which the printer understands, how to optimize that through slicing software that you need so that the printer understands really well what you're doing, and then get a result as on the picture. There's small drawbacks. If you do that, you will always, because of FDM printing, meaning we are literally a tube of toothpaste that you start squeezing and the material comes out, and you build up the model that you have envisioned, just like the picture. Well, that means your end result will exist out of lines that are stacked upon each other, and in the end result you do see those lines. Those lines are minimizing faster and faster because the printers become more accurate, thinner, finer and faster. But I wanted to highlight this. This is most of the time the easiest way to enter. Now, you see on that picture that we have today the ability to surpass that. On the right hand picture you see one of the snapshots out of how we used that ability of additive manufacturing and have also overcome what I mentioned myself in those visual lines, bring it into a benefit. And that benefit is unlimited and uncharted creativity in textures, in shapes and colors. You see on the picture from left to right various textures where normally in conventional manufacturing technologies these would have led to independent molds to be created. Read anything between $5,000 up to $50,000 for a mold that can have the visual aspect of what you see in the picture. Now, if we suddenly want to offer to our customer 10, 15 variances, then this becomes quite expensive and of course quite uncertain, because as a manufacturer you might not know whether all these textures will be liked by the market. Well, additive manufacturing allows you to do that without any of those costs, and more so inspire people to come up with more creative textures, more creative abilities, both in the color, the texture and the shape itself. And that's why today additive manufacturing has one thing that the conventional manufacturing struggled with: how to offer mass production also in a mass customized, mass personalized manner to the market. And that is what additive manufacturing does. Everyone can pick their flavor, design their flavor within the boundaries of the machine and within the knowledge of the engineering, but then get it for one piece or 10,000 pieces without the front-end investment and with a very measurable and fixed engineering cost. That's it. So I would urge you, keep on following all additive manufacturers around the world, because for the creative people, the best is yet to come. For those that are interested how we bring those solutions today to the market, the tool links are on the screen. You can happily explore those and see how every product from here on forward is a configurable product, not just on technology, but also on dimensions, also on colors and on textures. And then the end result are inspiring things like this, where linear elements will become something that in its texture, in its either translucency or non-translucency, in its architectural constellation will become standardized, a configurable solution for the market. These are the things that we're heading for with additive manufacturing. Simply put, for the customer, because in the end we can talk about the industry, we can talk about what we want, but freedom of design, ensuring that the latest states of technology is integrated, because you've heard it, we can print at any point in time what we want. So if there is new technology, in our case lighting technology, we do not have to wait until we've depleted a former stock or till we've depleted a former design, because those designs are only printed on demand anyway. So as soon as technology upgrades, we can integrate it, ensuring that the performance, whether it's energy performance, whether it's lighting quality performance is always integrated. We of course touched upon the sustainability, where I will round off this speech. And last but not least, do that very reliable and trustworthy, because everything is configurable and not depending on molds. Because everything you heard me saying is local. The global economy has changed, and that's why our factories for the US are in the US and work with a US supply base. The factories in Europe work for Europe, and in Australia for Australia. And that what is of course vital. That means that we can be fast to the market, close to the market, because we only print what the customer needed. That means our printers are always ready to accept that order 24/7 and start working on it. To give you very tangibly, typically you see in additive manufacturing that lead times can be 40 to 50% faster compared to conventional. Now I know some of you might say, hey, but conventional can also deliver in one day. Yes, it can. But then it won't be sustainable. You can deliver conventionally everything in 2 hours if you choose to, but the cost on our environment is incredible, because someone needs to stack huge volumes somewhere in a very big space consuming warehouse that is consuming energy, that is consuming that space, that is not necessarily great for our environment overall from its construction footprint, etc. Now, the only way you can still be quick without having that detrimental huge footprint on our environment is with additive manufacturing. So that's where it comes together. It's not a value proposition of one. It's a value proposition of all four. And I challenge you to find a value proposition that can hold all four. And that means we're not bound. I am for sure speaking to you from a lighting perspective today, that there is no segment you can invent that we cannot serve. All those segments have the same basic needs. They are confronted with this global changing economy change and need to more and more find localized solutions. All these segments and environments and customers, I am very happy to say, I see veering more and more to their social responsibility of doing something that will actually improve our climate, our planet, instead of being part of the further deterioration and of course all the consequences we live with, droughts, with floods, with an ever increasing temperature around our globe. I see that none of the partners we work with is blind for that aspect and is more and more choosing actively to be a contributor instead of a detractor. And then last but not least, all of these people, all these customers have one thing in common. They love to have something creative that is their brand identity, that is their personal choice. They all love to have the latest stage of technology integrated into their solution. And that's why I don't think I'm speaking today just from the lighting industry. I would evoke all and everyone to embrace additive manufacturing in all making industries, because those benefits are that I've mentioned and that I've highlighted are not constrained to just us. Now, I've been telling you quite a good show, and I want to close off with some challenges because it isn't all great. We have a challenge in public perception. We use polycarbonate, which in the public eye is a plastic. Now, you know that we have trained people, hey, plastic is harming our environment. We have the plastic huge patch in the ocean that we need to clean up. Well, we need to overcome that. We need to continuously educate people that it's not the plastics that were the problem, but actually the people and the behavior. And if we recycle them, we can actually come into a framework in which plastics, well recycled, can actually be one of the most sustainable materials that you can have, because they can make multiple loops into a circular economy. But we're not there yet today. We need to constantly learn. When I started with my team, and when the team started within Cooper a few years back, well, I can guarantee you none of what they learned then is still valid today. Additive manufacturing, material knowledge, printer knowledge, and software knowledge, all those angles that need to come together to have a efficient and fast and durable 3D printing, it's changing every day, which is cool because it's a constant innovative platform, but is also a difficulty. We need to manage all of that. The speed and the machines, the maintenance and the upgrades, the industrial setup that always needs to be adapted and upgraded. It is a challenge in mass production with additive manufacturing to literally stay up to speed. It's also a challenge of the creativity. On the left-hand side, you see a snapshot of one of our online configurators, as I told you we have. But I also highlighted the engineering and design community. So we see that one of the things that we need to upgrade and continuously teach, how does additive manufacturing work? What can it do? What can't it do? And that, of course, similarly as the machines and the software, in a continuously evolving, updating and upgrading environment. So it's also not easy for us, for you, to stay up to date. What is valid today, I'm pretty sure in 6 months from now, will again have evolved for the better. Doesn't make it necessarily pleasant and easy for us to follow. I promised you at the start that I was gonna, towards the end, and we're almost there, so thank you for your attention. Also highlight how far have we now come in our center point. We had the Global Economy Challenge and the Innovation Opportunity, but in the middle we chose, as Signify and as Cooper, to take the ability of taking sustainability towards a truly circular economy. I promised you to highlight what have we achieved. And what we see today with additive manufacturing, what you can do is that at least 65, and I'm happy to mention you, if you will go online next week, you will see 75, because we are upgrading our circular content. We have been able, because of our engineering community that is ever expanding and that is learning how to work with additive manufacturing, to reduce the number of components we use in our luminaires. Because one of the most important mantras of sustainability is use less. And if you can design smarter components, you simply need to use less, which is less sourcing, less trucks on the road, because those components that we print come from one spot, one factory that brings from that filament a product to the market. Because we have learned to make them more intelligent and smarter, we can start what we call design for maintenance and disassembling. I'm happy to share with you that none of our products use adhesives. All of our products have restrained the use of difficult screws and other adhesive manners, so that you, as a consumer, professional or private, have the right to repair your luminaire. You can take it apart, you can repair that single component. We of course offer all those components because it's 3D printing. We will offer them for decades to come because we don't have molds. So don't be afraid, you never get that phone call, oh sorry, we discontinued your component. And of course, more importantly, if that product would ever come at the end of life, that those that need to recycle it, ourselves or third parties, can take the luminaire in its raw components easily apart and recycle it perfectly as it should. We have measured that because of our local setup, restricting overseas transports, restricting, as I mentioned, because we use fewer components, because we use filament, which is transported very compact. We're not transporting components that have a lot of air. All of that has led to a carbon emission reduction of more than 76% on the manufacturing itself, 28% on the transport. We've been able, as Cooper and Signify, with our efforts that we take as a company overall, to get to carbon neutral production setups and have enabled energy consumption to be reduced with 85%. You heard me telling you that in our value proposition to the market, the latest stage of performance and technology is integrated. Well, this is one of the tangible proofs. I'm also very happy to state to you that we don't have overstocks because we manufacture what the market demands. So again, smaller warehouses, not waste in energy or whatsoever. If we do have a print that goes wrong, we can recycle it within our own premises. The polycarbonate can be simply shredded, put back into a filament extrusion line that we own too, and we can reprint with it. It's not across the globe because that would not be true. It is the case in Europe. We're working on that in the US, almost there. But in the US, we do have partnerships in the end of life to ensure that the product is fully recycled and the materials neatly get into a waste stream for reuse. So that's where we have come. That almost concludes my entire speech. I see that I almost made my time frame that I set out to do. I will leave you with one small video that takes about 35 seconds. That's simply for Cooper and for Signify MyCreation brands, so US and Europe, highlights where we have come, what you can expect from us today in a nutshell.
Imagine designing outside the box, creating beyond every catalog, and realizing all you wish for in a brand new, sustainable way. Dream out loud in every dimension. Feel the absolute freedom to follow your own vision and reshape the future. More durable, more beautiful, without blueprints or boundaries, without restrictions or restraints. It's time to create your own signature and bring the circular vision to life. Signify MyCreation. Remarkable lighting, sustainably printed.
So I do thank you for your attention. I do thank New York CX Design, Cooper Prentalux. I hope you have seen that additive manufacturing can really respond to the global economy shifts that we see today. I am convinced that you will join the additive manufacturing expansion because it holds the key to help us overcome our climate challenges. And I encourage you to follow many additive manufacturing platforms because it's constantly innovating. And last but not least, because we're of course now talking about New York and design, and encourage you to learn it and explore it because it holds a world of creativity at your fingertips. You can count on us as Cooper Prentalux and Signify MyCreation to keep on driving it forward. Thank you very much, and I wish you an excellent day.